Hey guys, so this is going to be an extra example for 6.1. At the bottom of the notes, if you pull up my notes, I show an extra example. And so I wanted to make sure that there was also a video for that if you wanted to actually see like another one worked, another one of these problems. This problem doesn't specify whether I'm going to use Gauss or Gauss-Jordan elimination. I'm going to use Gauss-Jordan elimination just simply because by doing Gauss-Jordan, I also do Gaussian elimination. And so you kind of get to see both that way. And you'll get to see it all the way from the system of equations all the way out this time. Because last time in lecture video 6.1, I just kind of start halfway through one of our other problems and finish it out. This way you can see it from the very, very beginning. So I'm going to do Gauss-Jordan. That means I want to get to simplified row echelon form. It's where I have a diagonal of ones with zeros everywhere else. But I have to get to row echelon form first. So here's my system. It's the same one that's on your page that I'm screen sharing with you, right there at the bottom where it says extra example. So if we are doing Gauss or Gauss-Jordan, our first step is going to be to write our augmented matrix. So for equation number 1, that's 2, 1, 2, vertical bar 18. For equation number 2, that's 1, negative 1, 2, 9. For equation number 3, that's 1, 2, negative 1, and 6. From our augmented matrix, the first thing I want is I want to get a 1 in the upper left-hand corner of my matrix. Since this is the very first one that I'm wanting to find, I need to look and see if I can flip-flop one of my rows to get a 1 up there. And I can. I can flip-flop either of my rows to get up there. But I'm going to flip-flop rows 1 and 2 around so that I can get a 1 in the upper left corner. So row 1 is going to switch with row 2. That means my row 3 is going to stay exactly the same, so I'm going to go ahead and copy it first. Row 2 is going to become my new row 1, and row 1 is going to become my new row 2. Now I'm here. Now remember, I'm trying to get 1, 0, 0. So I need those two spots to be 0. And when you're looking for your zeros, that's where you're going to do your third row operation, where you multiply a row by a number and then add it to another row. So I'm going to do both of these on the same matrix. That's mostly just to save some space, but I'll walk through exactly what I'm doing. So let's just look at that first 0. There's a 2 in there right now. I need it to go to 0. So what do I add to 2 to go to 0? Well, I add negative 2. So I'm going to take row 1 times negative 2 and add that to row 2. That'll get me a 0 right here. And I'm going to think about this one. This one needs to also go to 0. So what do I add to 1 to get to 0? I add a negative 1. So I'm going to take row 1 times a negative 1 and add that to row 3 to fix the 0 there. And I'm going to slide you down so you can see, because the original problem's right here on the screen. And I'm going to do both of these in the same matrix. So the only row that I am not messing with is row 1. So it's 1, negative 1, 2, and 9. Now I'm going to concentrate on row 2. I'm going to concentrate on that first 0. So I have negative 2 times row 1, and then I'm going to add it to row 2. So negative 2 times 1 is negative 2. I add that to positive 2, and I get 0. Negative 2 times negative 1 is a positive 2, and I add that to a positive 1, which will give me 3. Negative 2 times positive 2 will give you a negative 4. Add that to positive 2, and I have a negative 2. Negative 2 times 9 is negative 18. I add that to row 2, and I get 0. So that was doing this top equation S. This top row operation affected row 2. My bottom row operation is going to affect row 3. So I'm taking negative 1 times row 1 and then adding it to the corresponding elements in row 3. So negative 1 times 1 is negative 1, and adding that to positive 1 will give me 0. Negative 1 times negative 1 is a positive 1. Adding that to 2 will give me 3. Negative 1 times 2 is a negative 2. I'm adding that to my negative 1 to give me negative 3. Negative 1 times 9 is a negative 9. And I'm adding that to positive 6, which will give me a negative 3. Now I've got my first column all situated. What I want next is for that term right there in the middle, that 3 needs to be a 1. Remember, if you are trying to get your 1s, then you're going to do your second row operation where you multiply by a constant. So what times 3 will get you to 1? The answer is 1/3. So I'm going to take 1/3 times my second row. I have to do the entire row, not just that one individual element. Okay? So rows 1 and 3 are not going to change. 0, 3, 1/3 times 0 is 0. 1/3 times 3 is 1. 1/3 times negative 2 to negative 2/3, and 1/3 times 0 is 0. Notice that we got a negative 2/3 in there. That is okay. You can have fractions in your matrices. There's nothing wrong with it. Okay? So don't get scared just because there's a fraction in there. So we have 1, 0, 0, 1. We need this to be a 0. So what do I add to positive 3 to get us to 0? Well, I add negative 3. So I'm going to multiply row 2 by negative 3 and add that to row 3. Now we can get a 0 down there. So rows 1 and 2 are not changing. What is changing is row 3. Negative 3 times 0 is 0. Add to that 0 is still 0. Negative 3 times 1 is a negative 3. Add that to positive 3, I get 0. Negative 3 times a negative 2/3 is going to give me a positive 2. Add that to negative 3, and I get a negative 1. Negative 3 times 0 is 0. Add to that negative 3, you get negative 3. So now our first two columns are good to go. We have 1, 0, 0, 1, 0. So what we need next is to get this negative 1 to be a positive 1. And when we're trying to get our 1s, that's where we multiply by our constants. So what do I multiply negative 1 by to get to positive 1? Well, I multiply it by negative 1. So I'm going to take row 3 and multiply it by a negative 1. I'm going to move you over. Okay. So rows 1 and 2 do not change. Two-thirds, 0. Now I'm taking negative times row 3. Well, negative times 0 is 0. Negative times 0 is 0. Negative times negative 1 is positive 1. And negative times negative 3 will give me a positive 3. Now we have row echelon form. This is great if we're doing Gaussian elimination because then we would be done. But we're going to do Gauss-Jordan so that we can finish it out and see how it plays out. So what that means is that I need to have zeros in these other spots above my ones as well. And just like with Gaussian elimination, we focused on our columns and we got them situated first with our ones under and our zeros under the ones. Now we're going to focus on our columns, but we're going to do our zeros over our ones. So the first zero I'm going to focus on is this top -1. And luckily for us, if you look, row 2, if I add row 2 to row 1, that's going to immediately get rid of that -1 for me, which is what I want it to do. So I'm going to do that. I'm going to just simply add row 2 to row 3. I don't have to multiply by anything because simply by adding them together, or excuse me, row 1 and row 2, I'm doing row 2 to row 1, and I'm replacing row 1. So row 3 stays, row 2 stays, and it's row 3 or row 1 that's going to change. So 0 plus 1 is still 1. 1 plus -1 will give me 0. -2/3 plus 2, well, let's go down here. 2 plus 2/3, that would be 2 over 1, so I need that to be over 3. So it's going to be 6 over 3 plus 2 over 3, which is going to give me what? 8 over 3. Well, it's not what I show on my paper. Oh, because it's negative. Excuse me. Minus. So it's 4 over 3. Sorry about that. And then row 2, 0 plus row 1, that'll still leave me with a 9. So we got our 0 there. That's good. Now we need 0 here and 0 here. So how do we do that? Well, the best thing to do is to look in that column and think about, there's a 1 down here, which is great. So we know we're going to play around with row 3. We're going to multiply row 3 by something and add it to row 1 and add it to row 2. So what do I add to 4/3 to get to 0? Well, you add -4/3. So I'm going to multiply row 3 by a -4/3 times row 3 and add that to row 1. Why am I not doing one of the other rows? Well, because neither of them have a 1 in that position. Also, if I'm looking at row 2, what do I add to -2/3 to get to 0? Well, I would add a +2/3. So I'm going to take 2/3 times row 3, and I'm going to add that to row 2. I'm going to do 2 steps at once, just like I did earlier. I will talk you through each and every element that I get. Okay. So if I'm changing rows 1 and 2, then the only row that's going to stay is row 3, which is 0, 0, 1, and then 3. Can you see? Over just a little bit so you can see the previous matrix, so you can see where I'm getting some of my numbers. Okay, so we're going to start with this -4/3 times row 3 and adding that to row 1. Here's the nice thing. -4/3 times 0 is 0. We add that to row 1, it stays the same. -4/3 times 0 is 0. We add that to row 1, it stays 0. -4/3 times 1 will give me a -4/3. We add that to +4/3, we get 0. So see, the math is pretty nice. -4/3 times 3 will give me a -4. I add that to 9, and I get 5. So even when you're dealing with fractions, it's not necessarily going to give you really yucky answers. And right there, we've finished row 1. We're going to do the same process for row 2, only we're taking row 3 times +2/3. But the math is still going to be really nice because 2/3 times 0 is 0, and we add that to 0, we get 0. 2/3 times 0 is 0. We add that to 1, we get 1. 2/3 times 1 is 2/3, but we add that to negative 2/3, and we get 0. 2/3 times 3 is a positive 2, and we add that to 0, and we get 2. And remember, this is Gauss-Jordan. Once we get the reduced row echelon form, where we have a diagonal of 1s with zeros all around, then our solution is simply right there. Because our system of equations, if we write it, would be x equals 5, y equals 2, and z equals 3. Or our set is the ordered triple of 5, 2, 3 inside of your curly brackets because it is a set. And that is the extra example for 6.1.